We're starting with sketches. We'll start with graphs of absolute polynomials. So we are going straight to question 9 first. A, f of x is equal to absolute of x minus 2, x plus 4 squared. So the first thing I do is I write this as y, x minus 2, x plus 4 squared. You see that? I don't put the absolute first. So then what I do is I equate this to 0 to find the x-intercept. So I'll have x minus 2 equal to 0 and x plus 4 squared equal to 0. So meaning x is 2 or x plus 4 is 0. So x is negative 4. Now I want to find the y-intercept. I put 0 where there's x. So I'll have minus 2 multiplied by 4 squared. That is negative 32. And then I put the sketch of y. So I have negative 4. I also have positive 2. Okay, now they were supposed to be 3, but we only have 2. Okay, and then the y-intercept is negative 32. Meaning that in between here, the function is turning like that. We have no problem there. The problem we have is it going above 2 or is turning at 2? Is it going above negative 4 or is turning at negative 4? So we need to check at least one side. So let's check what happens when x is 3. So we're going to have 3 minus 2 and 3 plus 4 squared. So this is a positive number, bigger than 2. So it means that this side, it will go up, meaning that this side, it will go down. You just test one side. If one side it goes up, then one side automatically it has to go down, because a polynomial needs to have 2 turning points. Now, this is the graph of y, but you're supposed to put the graph of f of x. So now this is for f of x. What is it saying? It's the absolute. The absolute values makes a negative number positive. So what was negative 32 as the intercept becomes positive 32 as the intercept. What was negative 4 remains negative 4 because this is the x value. Positive 2 remains positive 2 because that is the x value. This line which was going down, this line which is below the x-axis, under the absolute, it is above the x-axis because we don't have negative values. And then the curve that was down, again, under the absolute, it's above. And what was up remains up. So this is the graph of f of x. So what I'm trying to tell you here is that whenever they ask the absolute of a polynomial or a quadratic, you first forget about the absolute. Sketch the normal polynomial the way you know it. When you are done, get back and check your absolute. and then flip it where it's negative, push it up in the positive. If they put a negative absolute, then it means that you must push everything that is above the x-axis. You push them in the denominator. I mean, in the below the x-axis, because nothing then must be positive if the absolute is negative outside. And that's what I meant by I will just comment on that one, because I know you know how to graph polynomials, you know how to graph quadratics. So if they put them in the absolute, they are telling you that, okay, when you're done sketching, can you now respond to the positivity of the absolute value? Unless we have questions there. Or we can do another one. Let's do B. F of x is equal to x plus 1, x minus 6, x plus 2. Again, y equal to x plus 1, x minus 6, x plus 2. Then we find x-intercepts. Meaning, so x plus 1 equal to 0, x minus 6 equal to 0, x plus 2 equal to 0. So we have x is minus 1, x is 6, x is minus 2. The y-intercept. Remember, when x is 0, so we have 1 times negative 6 times 2, which is negative 12. And then first we sketch y. So y has intercepts negative 2, negative 1, and positive 6. And the y-intercept is negative 12. So we have a function like that. We don't know where it's turning, but it's in this interval. Like that. So this is easy because just look at where the intercept is to know the orientation. It could not go this side because where is it going to cut the y? We don't know. Okay. So you don't take it there. So now this is the graph of y. This is y. Now I want the graph of f of x. The graph of f of x has the same intercept, negative 2, negative 1, positive 6, except that it does not go below the x-axis. So this remains the same. This remains the same. But this negative 12 now becomes positive 12. And so the function is now up. And where it is going down after negative 2, it goes up. And that's how we put the graph there. This is now f of x. So when you're looking at C, you first factorize C. You know how to factorize a polynomial. We did that. After you factorize it, will look like B in the absolute. Then now forget about the absolute. Deal with the y, sketch it, and then apply the absolute later. All the questions down there have power 3, so they need you to factorize. We know how to do that. You look for a number that makes it 0, via synthetic, factorize, and then sketch, then apply the absolute. Hope that's fine. Let's go to question 8. Rational. The rational functions. We'll start with B. F of x is equal to 6 minus x over x minus 3. The first thing I do is to find the vertical asymptote by equating the denominator to 0. This is the vertical asymptote. Then the horizontal asymptote. You look at the powers of x. If the powers of x are equal, then you say y is equal to negative coefficient, the coefficient of the numerator over the coefficient of the denominator, only the highest powers. So here we have x power 1, x power 1. So we get their coefficient, not the power, but the coefficient. So we get negative 1. Then we go to sketch. So we have two asymptotes. We have y equal to negative 1. We also have x equal to positive 3. After you put the asymptotes, you go to the vertical asymptote. So we say positive 3. Pick a number bigger than 3 and the other number less than 3. So you can see whether your graph is above or below the horizontal asymptote. So let's start with picking a number less than 3. Let's pick 0. So what is f of 0? F of 0 is 6 over negative 3, which is equal to negative 2. Negative 2 is below negative 1. So we're going to have the graph in this interval crossing at negative 2 because we have used 0, which gives the y-intercept. Pick a number bigger than 3. Let's use 4. What's f of 4? 6 minus 4 over 4 minus 1. That's 2 over 3. The number is positive, obviously above. So the curve is going to be up here. It doesn't touch the asymptote. Now it has crossed the x-axis. How do I find the x-intercept? I equate the numerator to 0. So we'll find negative x equal to minus 6, meaning that x equal to 6. So that is 6 there. Remember, to equate the numerator to 0, you are looking for the x-intercept. To find the horizontal asymptote, you are checking the powers of x. To find the vertical, you equate the denominator to 0. And that's how you sketch your graph. For as long as you go in that quiz, there will be this function to sketch. Sketch a fraction. It will be there. So if you think all is well, if you don't ask, then you're lying. Let's go to E. F of x is equal to x plus 3 over x squared plus 4x minus 5. So first thing, vertical asymptote. We equate the denominator to 0. So it becomes x squared minus x plus 5x minus 5. So we have this. So this and this. Like that. So we have these two vertical asymptotes. The horizontal asymptote. We check the numerator. The power of the numerator is 1. The power of the denominator is 2. The denominator has a higher power. Therefore, horizontal asymptote is 0. You will never have a case where the numerator will have a higher power. That case is not there in this course. So you are safe. You only have two cases, either 0 or you divide the coefficients. Now, when it is 0, you can still go back and check, will there be the x-intercept? Of course, yes, at -3. So the rule of the vertical of the horizontal asymptote will be broken there. We are going to have a special intercept on the asymptote. So we can sketch. Vertical, we have 2, 1, and -5. Horizontal, we have 1. This one. Then now we go to between -5 and 1. Let's pick a number there. So let's pick 0. What is f of 0? So f of 0 is 3 over -5. That is here, minus 3 over 5. But at -3, we have identified that there will be an intercept. So this is going to come like that, but we're going to put a hole here. And then put a graph like that. Okay. Then after 1, let's pick 2. What is f of 2? F of 2 is 5 on top over 2 squared. That's 4 plus 8 minus 5. This is 5 over 7. Positive, so the graph is here. Then let's get -6. So we have -3 up over, I can use this, that's -7 multiplied by -2. So get -3 over 14. Negative, so it's below, so it's going to be here. The graph has been put. No worries. That's our sketch. Even if I have 2 vertical asymptotes, I can still have the graph. I can still have a graph. Okay, so if you check all the questions, the maximum has 2 asymptotes, the minimum has 1, and we've done both. Unless there are special questions, you will still be able to ask, as you have always asked. So now we can drink water on question 7. Solve the equation. So you multiply throughout by 3x. You multiply throughout by 3x just to get rid of the denominator. So we're going to have 3 equal to 4 plus 3x. I hope you understand that. Because this is not like greater or equal to what, so we multiply throughout. And so now we're looking for x. So we have 3x equal to 3 minus 4, meaning 3x equal to minus 1 divided by 3. So x equal to minus 1 over 3. Let's do another one. This one was too easy. Let's do C. X power negative 4 minus 8x power negative 2 plus 15 equal to 0. So here you let y be equal to x power negative 2. This one in the middle. So that if you square y, it will be like x minus 2 squared, which becomes x minus 4. The powers multiply. So it will be negative 2 times 2, which is negative 4. So now we can go back and substitute. So we're going to have y squared minus 8y plus 15 equal to 0. So we can write this as y squared minus 3y minus 5y. And then solve for y. So we'll have y3, we'll have y5. But what is y? Y is x minus 2, meaning 1 over x squared equal to 3. So we get 1 equal to 3x squared. Divide by 3, so we have x squared equal to 1 over 3, meaning x equal to plus or minus root 1 over 3. Go to the other one. Again, x that equal to 5. So you do the same. Okay? You can actually do it in a simpler way. You multiply by negative 1 over 2, even the other side as a power. So it means with x equal to 5 to the power minus 1 over 2, meaning it's plus or minus root 1 over 5. So the key thing is that if the power looks not good for you, you can change it to something that is quadratic. For example, d is x power 6.